Okay, you good now? Great.
Yes, and we're recording now.
Okay, thanks.
Go ahead, Mike.
So, hi everybody. Thanks for having me here. I'm Michael Geronimo from Open Robotics. I've been with Open Robotics for a couple years now. Before that, I spent over 23 years at Intel and a couple companies before that. So, I'm the technical lead from Open Robotics on Space ROS. And this is a presentation that Jeff Biggs and I did at ROSCon with a few extra slides because we have a little more time. So I don't have to tell this audience that ROS robots are everywhere on Earth. So part of the presentation, I think I'll eventually get to the tools and processes part that we've been working on. But first, a little background on what Space ROS is and kind of the motivation behind it. So given ROS robots are everywhere on Earth, they're also robots are used in space. So there's rovers and manipulators and even little free-flying helicopters that have been used on Mars. And there's quite a variety of robots that are in use and will be in use, from manipulators and humanoid robots like Robonaut 2 and Robonaut 5, and rovers like the Viper rover there on top, and robotic spacecraft and landers. So there's quite interesting and long roadmap for space robotics coming up. And there's an increasing amount of software on these systems, from the Lunokhod of 1970, which was the first rover deployed from the Soviet Union, and up to the rovers of today on Mars. There's quite a large increase in software and complexity, which is driving demand for reuse. And you're already starting to see this reuse in the space, in space robotics and space systems. There's frameworks like F Prime and the Core Flight System. These are frameworks that for communication and for flight systems that have been flown many times, and they have kind of a plug-in architecture that people can write components for. And we're also, there's there's mission control systems like YAMS and OpenMCT as well. And they're starting to use open source as well. The previous ones that I mentioned are open source, and pulling in other open source libraries as well, such as AprilTag, which was used on the Perseverance rover. F Prime, to go in a little more detail, is, you see things like C++ framework, component architecture, library of components, associated tools and testing tools. This is typically used for smaller systems like satellites. And CFS is a very popular one. It's similar, but they're looking at reuse and cost savings. These are kind of the driving factors for these systems. ROS itself has actually been to space in a couple times in Robonaut 2 and Astrobee. These were limited circumstances. They made safety cases for that. On the right, you can see the Astrobee free flyer that can host science experiments on the ISS. And also there was Robonaut 2. So a little bit of ROS already coming into space in those limited situations. And coming up is NASA's Viper, which is a mission to the lunar South Pole in 2024. They're prospecting for resources, looking for water in particular, and performing science experiments as well. In this system, ROS2 will be used on the ground software, and it's also making heavy use of Gazebo. So there's simulation of the lunar surface. There's a lot of tests run against this system, and it's also using the YAMS and bridging from CFS to ROS. So in order to get on the flight software side, NASA requires software used in flight missions to be space qualified. And this is kind of driving the need for a version of ROS for space applications. So what Space ROS is all about is an open source robotics framework, space robotics framework, in order to develop flight quality robotics and autonomous space systems. That's kind of what we're striving to achieve. And the goal is to ease the adoption of the ROS framework into space robotics systems. And how we want to do that is to have it to be certification ready. In other words, provide artifacts provide the software along with artifacts that are aligned with aerospace standards so that they can be used in a certification. And also, which is very important, is bring the benefits of ROS to space robotics in terms of open source and open community. So there is some open source. For example, NASA will open source things like CFS, but it's not the kind of vibrant ecosystem, for example, that ROS has around the packages. So in summary, kind of a space certifiable and reusable robotics framework that would support flight software standards like DO-178C, which is an aerospace standard, and NASA has their own internal documents and standards like NPR 7150, which is kind of a high-level meta requirements almost, and provide artifacts to allow projects to gain a head start in their certification efforts. So we want to understand what those artifacts are and be kind of have more of a continuous qualification is kind of the idea, to be always providing and updating the artifacts. We want to be aligned with NASA so it can be adopted for the highest levels of missions eventually, and then enable rapid development of capabilities and facilitate reuse, and as I mentioned, open community. So instead of so being able to leverage ROS2 and the expertise with ROS2 and university and all of the vibrant ecosystem, and not just do prototyping, but have a path towards flight software. Space ROS started probably almost a couple years ago now between Blue Origin and NASA. And Blue Origin brought in open robotics about 1.5 years ago, and our role has been growing over time. And this year we've contributed quite a bit. And so what exactly is Space ROS? You can kind of think of it in three larger buckets. There's the foundation. At least over this last year, 2022, this is what we've been up to. So there's foundational stuff, which is like the things that Open Robotics does quite well: the builds and releases, the CI, maintenance of packages, all of those, kind of the heartbeat of the project. We've also selected a subset of packages from ROS2 to focus on as far as what's in the core of Space ROS. We've created several Docker images of the core, of Move It 2 built on Space ROS, and some sample applications as well built on top of that. We're also targeting some embedded systems, in particular RTEMS. So we're just now working on a project to bring up the core on RTEMS. But that's the basic foundation. It's basically the typical things that we would do at Open Robotics. And then the center areas where Jeff and I presented at ROSCON, it was really focused on the tools and processes. We've been focused quite heavily on requirements tools in particular, and traceability and analysis of requirements. So we've wanted it to be open source because, that's kind of our, high level objective, is to have this be open. So there are a couple tools that I'll talk about, and there's Doorstop, which is an open source requirements management tool, and NASA has a tool called FRET, which can be used to analyze requirements. So we've also focused on code analysis tools quite heavily over the last year, and we've augmented the standard ROS code analysis tools with a couple more from NASA. One's called ICOS, and another is called Cobra, and I'll talk about those as well. And so given the code analysis tools and the output that they generate, which is a standard serif file format, static analysis, resource interchange format, we then are working on a dashboard to be able to visualize these issues and navigate through the issues and interface to systems for dispositioning and things like that. So kind of looking at the whole development workflow of using this, the dashboard and interfacing and addressing issues, and then how that works with the ROS quality level. We're looking at defining a higher quality level that comprehends requirements, where the ROS quality levels really don't have too much to say about requirements yet. And then currently working as well on adding an MCDC testing tool, multiple condition decision coverage, which is called out by DO-178C as a desirable test to run on the code. So we've been focused a lot on the tools and the processes this year. But Space ROS would also consist of space-specific functionality. So there's some other things that we've been doing, which is to add an eventing and telemetry subsystem. And Jeff is working on that, Jeffrey Biggs. And William Woodall has been working on using a PMR allocator, C++ allocator, and ensuring that the core of ROS2 properly uses the allocator that you provide in all cases. And we're adding sample applications, space-specific, like manipulation and navigation. And we're also organizing various space-related simulation assets to kind of pull this all together into more of a Space ROS SDK and supporting processes. So I probably don't need to go into detail on this part. This is just listing the stuff that we've been doing in the foundation. We set up a GitHub organization, automated builds, Docker images. You can get the binaries. Sorry, there we are. We have Serif output in addition to the normal JUnit output that allows you to interface into the Jenkins CI. We have Serif output, as I mentioned. We are going with the AutoZAR C++14 standard. So we've added support in a Cobra tool to analyze about half of the AutoZAR rule set. I'll talk about that in a bit. We're working towards, as I mentioned, more of this continuous qualification idea that could generate the output reports and artifacts to support certification and have them ready, and working on RTEMs. Another thing is also looking at using Earthly to provide a uniform environment between CI and local developer environments. So you could run exactly what would run in CI locally and ensure that things are running cleanly. But more to the point, I think I'll dive in a bit on the tools and processes. So we've been running these analyzers across the code, the core of the code, and starting to address the issues identified by static analyzers, and also upstreaming these changes into the core of ROS2. We want to avoid forking as much as possible. So any issues that we can upstream, we are upstreaming. Currently working on this, defining the process and associated tools, and using tools like to analyze the requirements for consistency and conflicts, integrating the MCDC tool. And for the ETS, which eventing and telemetry subsystem, we defined the requirements first for that subsystem, and then ran the requirements check on that and kind of ran through the whole process on that. I'm also working on backporting requirements for an existing package, starting with something easy like RCUtils, and documenting the process, because eventually we'll want requirements for all the core Space ROS packages, not just any new ones that we add, but be looking at backporting requirements so we can have eventually traceability through the different levels, and then updating the quality levels. So one of the things about requirements management in aerospace is that it would typically be managed through a proprietary tool, and that would be the process would be according to standards like DO 178C. The requirements need to be complete. You don't want software without requirements and highly detailed. And there would typically be multiple levels, from that very high level L0 type of requirements way down to detailed, maybe L5 kind of requirements. And being able to trace through them is essential. So we want to be able as well to go to kind of the requirements all the way down to the implementation, and then maybe even a link to the code or a test that verifies that, and then back. So these requirements are used to to support the certification process. However, on the open source side, as you know, I'm sure that requirements are typically non-existent or very lightly managed. If they are there, they may have gotten out of date a bit, and we're trying to avoid heavy processes. We don't want to discourage contributions and make the bar too high. So what we're trying to do is balance these kind of competing or conflicting sides, so from the strong processes of aerospace to the open source community. So a heavyweight requirements process and expensive tools is not going to work. So we need open source and kind of the right level of rigor on this, trying to strike a balance on this. So what we settled on is a tool doorstop. It's open source. It's a very straightforward command line oriented requirements management tool. You can create so-called documents and then add requirements to those, and then make links between those and see the hierarchy of requirements. These requirements are then, they're stored in a YAML files, separate YAML files for each requirement. Or you can also use Markdown, pretty similar, and human readable, easy to parse. You can write in natural language. You can use some restricted language like ears. But the main point is it's open source, freely available. We can modify it if we like. And it really meets a lot of and using Git for the, checking in requirements into Git, you have version history. You can have discussions about it. Excuse me. And then you can use a tool for analysis and traceability and walking through the requirements. So it does a lot of what we need. But on the other side, there's NASA's FRET tool, which is kind of a graphical interface with a database backend, and it does analysis of requirements, and it can do kind of model checking for consistency and conflicts. But in order to do that, the requirement has to be expressed in a language called Fretish, which is just a kind of a rigorous layout or syntax for requirements. Not that difficult to convert and ramp up on. And once you have the requirements in Fretish, you can then analyze them and check them for consistency and so on. And so freely available. Again, the learning curve probably a bit steeper than doorstop in order to learn Fretish, but it's a really good adjunct to doorstop. So we're looking at using both of these tools. And the interesting thing about Fret, and there's an associated tool where you can actually generate a safety monitor from requirements. So this safety monitor could be used during verification, kind of in a V&V process, where you could select the requirements from which you want to generate a monitor, and then that monitor can run as your system is running to verify that requirements are being met. So it's an interesting idea, but that's possible once you get the requirements into Fret as well. So this is kind of what we're thinking, as requirements coming in using doorstop and Git to capture them. And right now we're looking at how we can sync between Fret and doorstop. To do, like in Fret, you would do the validation. So the file formats are, we've just now implemented an import in Fret, although we're really driving towards just having a common file format. So you could have multiple tools working on the requirements for traceability, for validation, perhaps visualization, other needs. You could have a common format. So they're not too far off, but that's what we're kind of working towards. And then with doorstop, you can trace all the way into source or tests, as I said, or perhaps even generated safety monitors as evidence of satisfying that requirement. And then, of course, being able to generate reports. So doorstop also comes with a Python API that you can use to easily traverse the requirements. So you could also, it has a reporting feature built in too, but you can also generate custom reports too if you needed to. I think I basically covered all of this. This is the summary: doorstop for the requirements and traceability and generation of artifacts, and Fret used for analysis and consistency checks, having the single source of truth in Git, and being able to trace all the way down to the implementation and tests. Before I veer into static analysis, any questions on that so far? I was going to shift gears a little bit from requirements to static analysis. Okay, feel free to jump in if you have any questions. We've also spent a lot of effort on the static analysis side this year, in addition to requirements. So the intention is to, provide evidence again into the certification process about code quality, supporting verification. So ROS already had, several analyzers and code formatters. From Blue Origin and NASA, there was requests to add ICOS and Cobra. So talk about that in a sec, but we're also adding MCDC testing and code coverage. So the analyzers all generate serif. They don't do this directly. The analyzers have the output. I think none of the tools natively support serif yet, except for Cobra. But I think this is the format in the future that static analyzers will hopefully output directly to. So we're basically taking the output and generating serif by capturing the output from the tools and then doing the serif generation ourselves. We're also looking at, we've removed some redundancy in the output, because you can imagine running a static analyzer on multiple source files that themselves include the same header file. So it's quite easy to get a lot of redundancy from running these tools. So what we do is we take all the static analyzer output and we basically create a bundle. So when you run the full test pass over the source code, we have a bundle of all of the output and some meta information in basically an archive format. We have the original serif files, and then we post-process them to remove redundancy. And then we have the post-process serif files as well in the dashboard, in the bundle. And these results are then made available to our dashboard, which is currently a Visual Studio Code plugin that allows you then to view the output. And so we're trying to keep down the noise as much as we can. We'd like to remove what I was calling semantic equivalents, which are maybe multiple tools reporting the same issue, right? But they might have different verbiage, and if we can identify that and even improve further and cut down on the noise on the output. Another thing we're looking to do in the future is we've enabled a lot of these analyzers. We really want to find the right mix of the analyzers to get to balance the kind of signal to noise ratio and get the best results without having to have a burden of sorting through all of the output. So that's in process as well, that over time we'll learn which generate the highest quality output and what's the right set in order to capture the best results. So I mentioned ICOS a couple times. This is a, so back up a step before I describe ICOS. But the DO-178C, which is an aerospace standard, has an extension, 333, that talks about how developers can use static analyzers in certification. And 333 talks about using formal mathematical methods, and in particular talks about abstract interpretation, which is a methodology. I have got links at the bottom. You can look into this, but ICOS is a static analysis framework based on the theory of abstract interpretation, so that is an acceptable tool for 333. So it is a framework. Let me move on here. So it's basically, it uses LLVM front end, and it ends up with creating an intermediate representation that is useful for static analyzers. And so there are implemented analyzers, and you can also use it as a framework and add additional analyses if you like. So it's a very powerful one, very deep analysis, extensible, and this and in sync with the standards. On the other hand, there's another one called Cobra, which is entirely different. It doesn't work by doing a full parse of the source code. It only does a tokenization of the source code, and then it has rules across that token set. So you can, it works well, it scales up very well to really large code bases. It can, for example, take in the whole Linux kernel, and then you can have rules or queries against that whole entire set of token streams. So it's less powerful because of that. So it's using regular expressions rather than the full parse, but it can do a lot of code very quickly. So You can write your own checkers. It comes with a lot of different rule sets, like for the JPL rule set, common weakness enumeration rule set, power of 10 rule set. And we have added AutoSAR C++14, but because of the nature of the tool and because some of the rules in that are not automatically verifiable, we can get over around 50% of the checks done by Cobra. It also has an interactive mode, by the way, that we don't use. There's an interactive query engine, so you can just bring in a whole bunch of code and perform queries against it and do searches through the code for certain patterns that that are not desirable. So for these codes, we've written an Ament front end, like you have in ROS for all of the other tools. You know, there might be like Ament Clang Tidy, for example. So there's a uniform, pretty uniform interface with these tools. So we have Ament Cobra and Ament ICOS. Here's an example of Ament Cobra command line. So you have the typical include directories and exclude directories of all the Ament tools have that. XUnit output file, which they all have that. And now they all have the serif file output as well. So as I mentioned previously, this tool will collect the output of, say, Cobra in this case, and then generate the serif, corresponding serif. And serif, by the way, this is kind of the framework of the serif schema. There's information about the tool, version number, the schema used for the serif, and the real crux of it is there are runs. So there can be one or more runs for analysis sessions, so to speak. So you've got the tool info and the rules that fired for that tool. So it's empty here just to show you the whole structure of this. And then the artifacts that have been analyzed, basically the source files, and then the results. So this is the pretty basic structure, but you'll have a lot of rules that fire, a lot of artifacts that have been analyzed, and this result summary. So this format can be used by IDEs or output by code analysis tools, and we've got them on all of the tools. So this is an example of Visual Studio Code and the plugin, the serif plugin. So with this is how you would view the results. So I mentioned previously we create an archive of all of these results, and now you can navigate through these results. I've highlighted one here. And down in the lower right, you can see the details about the rule, the description of it, and the rule identifier. And then over on the left, it's kind of hard to see, but it's highlighting the line that it's referring to. Basically, just allowing you to navigate the code through all of these issues. It is fairly convenient. What we're adding to this plugin are charts and graphs. And at the request of Blue Origin, they wanted to see more project management level interface, so like burn down of issues over time, where are these issues coming from, which source files, which tools are reporting them, all of that kind of thing. So we have multiple charts that we've added to the Visual Studio Code plugin. So we have a GitHub repository for all of the Space ROS work, and this plugin is, along with all of the other code, is there. I won't go into that one, but on the space specific functionality, so that's basically what we're doing on the tools and process side. A lot of requirements, a lot of static analysis, visualization of the results. And on the space specific side, a really cool, a cool and important one is the CFS ROS2 bridge. I mentioned that CFS is quite readily used on the flight system, so we want to bridge an open source bridge to that. Track Labs is a company that is working on that right now, and we've been talking to them to open source their work, and it looks like that's going to be successful, where we have at least the core of their work is open sourced, and so that we can interface to CFS. I mentioned the eventing and telemetry subsystem and the memory allocators that we're working on. We also have navigation and manipulation demo apps. So we have Mars rover here, as well as the Canadarm. And we're currently adding Move It to the Canadarm. Previously, it was just built on space ROS, and kind of you could drive the mechanisms, but we didn't have the planning, motion planning, and now that's being integrated this week actually. And we don't have the navigation stack integrated yet with the navigation demo. It's similar. It's got the simulation and it's got the core of space ROS, and you can command it, but there's not the full nav stack to drive it yet. And then organizing the simulation assets. So what we're looking at, we want to integrate, in summary, kind of the open source tools and processes to improve code quality, requirements analysis, workflow, quality levels. And we're doing all this in the context of space ROS, but we have recognized certainly that it could be useful, the tools and processes in particular, to other domains. So we're looking, I present this quite a bit to other, ROSCON, elsewhere. And so we would welcome contributions and input, your thoughts about perhaps from the security perspective, of course, and tools that could or should be integrated. And we're also looking for, to collaborate on some of this, given that it's all open source. Yeah, so I think that's kind of that's the story. So any questions at that point?
Thank you so much, Michael, for a great presentation.
Yeah.
Yeah, I have a few questions, but please feel free to raise your hand or just jump in and bring up your questions for everyone here. I don't know the order, but Jeremy, Adam.
Right. Well, thanks, Michael, for a great presentation. That's really, really interesting. I do have a few small questions. And first of all, I understand from this presentation that most of your effort, or if not all of your effort, concern ROS, really. And I was wondering where does the system dependencies land into this certification ready effort?
Where I didn't hear the last part. Where does what land?
System dependencies. So all the
dependencies, yeah.
libraries on which ROS is based, and in a broader perspective, maybe the OS as well.
You're right. Yeah, that's an excellent question. Honestly, we've been focused on the ROS code and kind of the ROS quality levels, but there are many system dependencies, and how are those integrated and certified? It is a very large network of dependencies. I would suppose that, I haven't thought about this much, actually. I've been so focused on the ROS code, but I think that with, there are systems that have flown, like CFS, that are based on like an operating system abstraction layer. Inside CFS, there's another library that abstracts the OS, and that has been certified and flown. So I would imagine the lowest levels of ROS would have to be ported, and that is maybe to the target system, right? Like we're working on RTEMS, for example, and we have, right, ROS works with, Linux and Windows and so on, but there could be an abstraction or a mapping to something like OSAL that could encapsulate kind of the lower levels of the operating system, or something that's already been certified. I think that's how I would think about it or approach it, but honestly, I haven't kind of mapped out the dependencies all the way down, at least on Linux. I think you'd have to get it on top of something like that.
Right. And the question that's somewhat a follow-up to the previous one is, as part of the certification, are you asked to provide a software bill of material, or also known as SBOM?
My honest answer is I don't know. We haven't gone through the certification process. I've been, working with them on what are the kinds of things, the kinds of evidence, and trying to drive to the details. NASA does have, I will tell you this, NASA has another tool that's in development that's not open source yet, that is meant to help in the auditing process. So that is more like checklist based and so on. And so they're working on having, and I'm very interested in that because I think that would be another interesting, a good tool to integrate is something to support. So if you could say customize that for your particular standard and you're walking through the checklist, but I don't know specifically if they have a BOM of all of the binaries or elements that comprise the entire system. I don't know. A lot of these standards, from what I've seen so far, are very high level, kind of meta level requirements, and not very prescriptive about what you must do. So I think you're developing a case for the auditors, for the certification and evidence that you provide. It seems like to me, I'm a little bit naive because I haven't gone through the process, but it seems that the better evidence you provide could only help.
Thank you.
Adam, you want to jump in?
Sure. Could you give a little more detail on the work with the PMR allocator? And in particular, are there strategies for validating that the allocator is in fact being used in all places where we'd like it to be used?
I can try. Let me see if I have 1 second here. Yeah, William is working on that one. So what I think he's found occurrences, he had a couple issues on GitHub where he's ensuring that the allocator is used everywhere. So he found some occurrences and has made some fixes for that. So what we're trying to do with the allocator is that Space ROS applications could make use of a user supplied allocator, and it would be consistently used in all cases. And we're providing a sample application and a sample allocator that demonstrates the use of an allocator. And then he's documenting that. So the issues were that, he found some occurrences where it wasn't being properly used. Let's see what else here. Messages, there are currently no way to specify the PMR allocator. If messages contain strings or vectors, currently no way to use the allocator. So there's an issue entered for that. And I guess there's an issue with a CWrap C++ allocator, a couple more issues. So a lot of what William is doing here for the rest of the year is kind of cleaning all of this up and then documenting the use of that type of allocator and providing the example. So I can provide you these issues if you like, but that's about how deep I go with it. William has been doing all this work.
Okay, yeah, thanks. I guess the part of it, and maybe this is more of a question for William, is so the first bullet point there.
Whoops. Yeah.
Oh, just moved.
Yeah, sorry.
Like, so when we have these limitations, are those being found by inspection, by, debugger? Or is there something a little more?
Yeah. So kind of methodology he was doing, he was running this, and he had a package that would check for dynamic memory allocations like malloc and free and so on. So William, there was a package in ROS memory tools, I believe it is. And so William was running memory tools as he was running this, and that was helping him to discover allocations that were undesirable or that weren't using this custom allocator.
Thanks. And if I could go one more follow-on question with
Sure.
that. Are there particular RMW implementations that you're targeting, or is that meant to be up to the user who's deploying a system to pick an RMW implementation?
Yeah, the latter.
And the allocation work extend into that layer as well?
Yes, the latter. So it would be up to the application. We wouldn't necessarily dictate. And so, yeah, I think having these tools and processes that could be applied in different steps, there may already be certified middleware, or you could even write a CFS could be wrapped as middleware as well. We could bridge to it, or there's different architectures that you could envision. But I think the latter, we're not dictating the RMW.
Thanks.
Yeah, I have a couple questions as well. One shorter, one maybe a little more extended. So the first would be, can you comment on what are the requirements that you have to fulfill for in terms of security for certification? So I wasn't able to find like a link that I was sure was it. Feel free to share a link if that's an easy way to explain it. But I'm guessing by integrating all these tools and fixing issues, you're sort of aiming for a certain standard or following some a set of rules for what to be prioritized, for what kinds of issues are.
Yeah, we don't have like low-level requirements for it, but there are like documents like NASA's 7150. I think that get into security requirements. The project show, like for example, it's ensure security requirements of. There's a separate document that I haven't delved into yet. So, for example, 7150 does call out the security requirements of MPD 2810, right? So that's another thing we could look into.
Mm-hmm.
So sorry, we don't have the all of the requirements mapped out. That's what I'm kind of working on is what does NPR 7150 say? And can we make those requirements explicit in a tool like Doorstop? And then how do they map down through the rest of the requirements down eventually to packages? That's the type of thing that we're going for. We've been working on kind of the foundation over the last year of how would one do that. And now we're actually kind of starting to do that, which is to digest these documents and these requirements. And there is like a hierarchy of documents, for example, from NASA. They have the high level requirements and they have specific requirements here that then break down into other levels. And really how much we want to be aligned with this type of thing. We don't necessarily want to reproduce all of it, but we have to find what's the right level that we have captured requirements, right, for space ROS itself, so that we can be used by a system that is guided by this document hierarchy. Hopefully that makes sense. So we're trying to find our way to find the right level to support a NASA project like this without, redundantly doing extra work on our side. So it's a long-winded answer, but there is a document that talks about security requirements. So if you look for NASA 7150, and you can take it from there.
Yeah, excellent.
Yeah.
Thank you. That makes sense. I'll look at that one then. Then it's kind of related to a previous question, and it has to do with sort of your process when it comes to making use of the results that you get through these tools that you showed before. What does your security analysis process look like? How do you prioritize and triage the issues to be fixed, let's say?
How do we prototype the issues to be fixed?
Prioritize?
I didn't quite capture the gist of your question. So can you repeat that? Sorry.
Yeah, for sure. So how does your triaging of issues work? Do you prioritize just based on severity, what's being shown as more critical, maybe should be fixed first? Or do you choose some packages that if any issue is found in those, then it absolutely needs to be.
Are you talking about like from the static analyzers and so on, or triaging? And
yes.
Yeah, okay.
Yes.
Okay. I see.
Yes,
I did that. So far, we have, the way we've done it is pretty straightforward. So William took, say, Clang Tidy first, and he was looking at the output of just Clang Tidy. But you're absolutely right. We have thought a little bit about, that's the problem with all the analyzers. When you add in more analyzers, you introduce redundancy and kind of noise and things like that. And that was really what I was focused on. Is there higher quality from one versus the other? Or is there one that, like ICOS has been used by NASA before, and that's a really important one. Maybe we find that CPP check is just redundant and nowadays it's slow, so maybe we drop that. So we're kind of in the process of dialing that in, and what you say is really important. There could be categories of issues that are more important than others. That's kind of gets to the analysis of all that output. I've talked to people at NASA that have used static analyzers, and they have done things that are like really simplistic on project, which we're just looking at the top 20 issues right now because there's so much information that's generated. So even on a lot of these projects, I don't think they're sorting through and prioritizing, but I think that's a really good thing to be thinking about. Is there, you know, quality of analyzer? You know, maybe one has a really good output, and so that's prioritized, or certain types of issues are prioritized. You know, something discovered by a security checker or a memory-related issue. I think that that's something that would be helpful for us in that dashboard, to not just display all the stuff, but to be able to sort by different ways. We can currently sort by, or filter rather would be a better term, filter by analyzer. We can do that. We can't really filter yet by type of issue, but I think it's a great idea.
Yeah, absolutely. You have a lot of different criteria there to apply. So
Yeah,
that's interesting.
absolutely. Issue types, and we thought about kind of aggregating issues of saying, you know, all of these are in a certain class, so you have a hierarchy. That's one way to address the volume of issues. You know, gather all of the memory-related issues together, and if you could start thinking about them in terms of categories that you define, you could have then assign priorities to those categories, and that would be a pretty straightforward thing to do. You know, but you'd have to go through the issue types and classify them. And we thought about doing that kind of on the fly, being able to tag them, for example, tag an issue, create tags, associate tags with issues, and then filter on tags. That could go towards what you're talking about.
Yeah, definitely. And there's another question that you proposed related to the fact that this is all ROS code working on robots. So the question was, should development of a threat model be incorporated into this package analysis?
I think that is an excellent idea. You know, we're getting training right now on kind of the you know, safety culture and that type of thing, and we're reading a book, and it does mention that, you know, security now is kind of an intrinsic part of, you know, a safe system. It's hard to extract anymore. So I have been focused on requirements in terms of quality levels, but developing a threat model could certainly be something that is done for a higher quality package, for example, right? So I haven't been focused on the security aspect. I've been focused on the requirements, but defining like a quality level 0, for example, that could include security concerns, you know, as well as requirements related language, I think is a good idea.
Yep. If I may just finish with another quick question. Do you have an idea of how many issues you have fixed so far?
Oh, gosh. William has, I would say on the order of, because he's mostly been working with Clang tidy output, I would say in the order of 30 or 40, probably in that level, but I'd have to get William to comment.
Okay, so I'm actually curious to when you do make a fix, you mentioned that you propose them upstream as well, so it's available for the whole community. Do
Yes.
you set some kind of notification to, you know, let the community know this issue was found and fixed, or do you just leave it up to the maintainers, I guess? After.
It is, so when we make a fix, it's just like any other. There's you know, fix upstream, and there's not a notification per se. There's is that what you're asking about? So there's just a normal process on ROS 2. So he would William would submit a PR against a particular package where he found an issue, and sometimes it was things like to be able to you know, you're creating noise because one, you know, sometimes the analyzers are turned off by comments, and trying to make sure we can control the analyzers and not making spurious issues because of a particular format of things like that. There's all kinds of issues that he was addressing, both important and kind of trivial, just to increase the quality of output. But there's no special notifications or anything. It's just a normal process. But we can see, so we've been trying to upstream, the code as much as possible, but you could see over time, eventually, there could be, conditionalization, this could be generalized too with space. There could be more of a safe ROS. And at some point, there might need to be some code divergence. And you'd want to be as careful as possible with that. So you might have conditionalization, compile time conditionalization, or maybe there's runtime configuration, or maybe, there's a lot that we could do before having to fork a module. We want to avoid that because in William's experience with Apex.ai, for example, that can be very costly to maintain a fork. So we're trying to avoid it as much as possible.
And okay, just related to the last part, do you usually, when you find the fix, do you submit it as a CV to be registered as such, or just propose the fix?
Just propose a fix. So.
Okay.
I think I understood properly. I mean, it was just like, say, working on, we maintain a lot of the core ROS packages already. And if we find an issue through a static analyzer, it's just addressing the fix in the normal ROS2 workflow and submitting that PR and integrating it. And we're tracking Humble right now with Space ROS. So as fixes are submitted into the Humble branch, then we'll pick them up.
If I may jump in and following this line of discussion, it is my understanding that the artifacts generated by all those static analyzers, they are publicly available, maybe on the build farm, on the ROS build farm. Is that correct?
I'm sorry. Sorry. Some of the voices are a little hard for me to hear, so I didn't quite hear it. But you mentioned the build farm, and I heard that part. And
let me try to increase the mic sound. Yeah. So, am I correct that the artifacts of those static analyzer are readily publicly available, maybe on the build farm?
No. So what happens is there's a so right now we have Space ROS and Docker image, and all of the analyzers are available in that Docker image. And if you run like a Qualcomm test, it'll run all of the analyzers. And we also have the ability to create the archive from the. So once you run all the analyzers, the output is in the normal place in the build directory, as with like the XML files, the JUnit XML. Alongside there's also Serif. We can run another process that then aggregates all of those and creates the archive for the dashboard. So it's available during the normal test cycle. So you do a build, but you can also do a test, and that's during the test phase. That's where it runs all the analyzers. It's not yet we don't have the artifacts posted yet. That's what we want to go to, have a continuous integration where the artifacts are already available, but they're not posted as of yet. They can easily be generated through using the Docker image. We're also integrating Earthly, which it's kind of Earthly, if you're not familiar with it, is kind of a combination of Docker and Make in a way. You can have different targets. And so with Earthly, you could do a build, which would execute all the different Docker commands. You could run kind of the test, which would execute those. You could run kind of the packaging phase, which would create the archive. And so it's very easy to do yourself. And we do want to get to the point where all of this is just available after a normal nightly build. And Earthly actually helps us to do that because it creates all of these different steps. And those steps will be identical whether it's on the development machine or the CI machine. But right. as of yet, you'd have to just run yourself, Docker image.
Right, so it is already virtually public, the artifacts.
Right, not yet.
However, you may want to consider not making them public, because what if these tools were to pick up an actual proper security issue, and because of time constraint, resources, etc., they wouldn't have time to address it right away, then this vulnerability would be, publicly disclosed without any proper mitigation on the way.
That's an excellent point. Hadn't gotten there with kind of considering the security and vulnerability and reporting process and that type of thing. That's an excellent point. Thank you.
And I do have a last small question. If we were to add our own tooling to this framework, our own static analyzer, etc., where do we start?
So there are, where do you start? So that's a good point. So there's many examples of, so one of the things, if it's a static analyzer, we want to have common Serif output. So one place to start is to understand Serif. And then does the tool natively support Serif or not? Most certainly it doesn't yet. And so you would, how you would do that is look at one of the Ament tools like Ament Clang Tidy and how it works to interface to an external tool like Clang Tidy, and then how it generates a Serif output. So there are several examples in Ament lint repository on the Space ROS branch of how to implement these tools. There's not documentation as far as how to explain how to do it for somebody else. We've added a couple ourselves, but that's how it would be done. And I could certainly provide the information, but that's a good idea for an article. What we're doing is we have a Space ROS website and we have a Space ROS documentation site that's coming up. So we could write an article on how to add another analyzer, the steps that are going through that. I will make note of that. I think that's a really good idea if somebody wanted to add another one. But
yeah,
that's how
I think it would be really useful for working group if we could integrate some more security-oriented tooling to this framework.
Definitely.
It would be very useful.
Meanwhile, if you wanted to do that and we hadn't gotten there yet, I can certainly provide you a few pointers because I've done it multiple times.
Great, thank you.
If I may add another quick question, do you plan to continue using the same tooling for code analysis as you have so far, the ICOS and Cobra? Have you found that it works well in combination and for your purpose?
Yeah, so we need to make more use of ICOS. It's a very sophisticated tool and we haven't yet. Cobra works quite well for what it does. It's great, it's fast, a lot of different rule sets. You can write custom rules once you learn how to do that. That's a nice tool. ICOS is a very sophisticated tool and it works on, it works basically on, by starting at the main function and doing kind of a deep parse and looking at the whole program. So it's, instead of looking at individual source files, it really is more oriented towards the entire program. And we need to get to the point where we have our full examples running. Like I mentioned, the manipulator example that uses move it and things like that. So once we have a full stack, we can make better use of ICOS by pointing it at, either, in this case, we'll have to do multiple nodes, but basically you want to point it at a main and then it can analyze the code all the way through the dependencies. So I found Cobra to be very flexible, very easy to use, and ICOS very sophisticated, but we haven't made extensive use of it yet. We haven't realized its potential yet, let me put it that way. But I'm confident that it has great potential because it has been used and this was highly recommended by NASA.
Great. I think we're a bit over time already. I don't know if anyone has final questions, comments. Or Michael, do you have any requests for the group? Anything that you hope that we can help contribute to the project? Yeah, I think if you have any particular analyzers that you're looking at, I think that would be interesting to know, which ones and why, and hopefully would be aligned with our open source, intentions as open source analyzers that you think would be good to add.
That would be great information. And other points, like you mentioned, like we hadn't gotten to yet, like security vulnerabilities and, being careful not to just put information out there about a vulnerability. I think that's a very great point. So any type of, or if there were security requirements, those are kind of the areas I'm thinking about, is the analyzers and the quality level. What should we do, if anything, about the security? If we were to define a quality level 0 for ROS, what would it say about security? I guess that's another area. I have a good handle on the requirements, but not necessarily the security aspect.
Are you referring to setting some kind of security standard for ROS packages?
Yeah, it doesn't. There's nothing really said, is there, or that I recall about, to achieve the highest quality level. Is there anything security related that should be done for a package? Is there an analysis that should be performed, or should there be a consideration of a threat model for that package? Anything that should be introduced. We can imagine the highest quality level, there should be requirements specified for the package, right? Something like that. The requirements could be analyzed to make sure that they're consistent and non-conflicting and all of that. So I can imagine statements at the highest quality level that are requirements related, but should there be anything about security? Should you run some type of scan? Should you do any analysis to achieve the highest quality level for a package?
Right. So there is nothing of that sort defined today, but that's definitely something we should be looking at. That seems like an opportunity to do so.
Well, great.
Great. Thank you so much, Michael. If we wanted to contact you, we can just do that over email and follow up this
Yes.
really interesting conversation.
Yeah, feel free. Please do.
Okay, sounds good.
All
Thank
right.
you again.
Thank you all. Appreciate it.
Thank you very much.
Have a good day.
See you.